Hi everyone, welcome back to the channel. Let's look at this problem. There are two spring dumbbells comprises two balls of mass m each. So this is m, this is m, all the masses are m, and the stiffness or the spring constant is k. Okay, and at certain moment they are both approaching each other with velocity v0. Okay, and the distance between them from the ball which is leading towards each other is L, okay, at that moment. So the question is, after what time is the distance between them equal to L again, assuming that the collisions are perfectly elastic. So if you see, what happens is that these two are approaching each other at middle point somewhere here. They will collide with each other and then they will go back, and then we need to analyze what happens. Okay, so let me first give you some concepts here. Okay, this is a typical two-body problem attached with a spring, and there are too many questions that we see, in examinations or elsewhere. We need to get the concept clear, and once we understand what's going on, how to handle such problems, it is not going to be difficult to solve this kind of problems. This is a tough problem, by the way, typically targeted for Olympiads or even higher exams. Okay. But IIT JEE can ask such questions, and previously, if you see, in previous years, they have been asking such questions. Okay, so let me just give you some concepts, and then you can give it a try, and then come back and see my solution. Okay, so let's call it two-body problem. Although it is not restricted to two-body, but let's deal with two-body problem because typically we get the questions involving two bodies only. Okay, so in two-body problem or multi-body problem is defined as a system where the masses or the particles are interacting with each other. There are forces between each other, and that's how they are moving. And then we reduce this problem to a single body problem. Okay, and using the concept of reduced mass. Okay. That is the concept from very high level. Okay. So let's see what happens. So let's take this example only. There are two bodies here. Let's say both mass. Let's say for the sake of discussion, mass m1, m2. This is particle 1, particle 2. And there is a force on one, let's call it 1, 2, because the forces are there because of each other. Okay. And this one will have, let's say, 2, 1. Okay. So we know that F21 is nothing but minus F12. It is pretty evident, right? So let's say that this one is moving with acceleration A1 and this one moves with acceleration A2. Okay. So what is A1? A1 is nothing but F12 by M1, and A2 is F21 by M2. Okay, so if we need to calculate the relative acceleration, that will be A1 minus A2, which is F12 by M1 minus F21 by M2, and we know F21 is minus F12, so we can simply write it as 1 by M1 plus 1 by M2 F12. Okay, and therefore F12 we can write as mu relative acceleration, where mu is M1 M2 by M1 plus M2. Okay, this is as simple as that. There is nothing beyond this. Okay, now the relevant question here is, what is the application of this two-body problem? Okay, and you can apply it in, let's say, in the case of planetary motion, where two masses are moving under their own influence. So let's say this is mass m1 and then this is mass m2. And here the motion is because of their interaction. And the force here is nothing but the gravitational force, right? So second application, we just saw that this body is attached with a spring. right? And when they are free to interact with each other and they move because of their own interaction. There's a third interesting one here is when we want to calculate, let's say, moment of inertia. Okay. Now, let's say there is a mass m1 and they are attached with, let's say, some massless rod of length L, and the other is m2. Then we can write the moment of inertia for such system as mu L square. And this is pretty easy to prove. I leave it for your exercise because let's say if you calculate the CM, let's say this is at L1 and this distance is L2. And then once you figure out the I as nothing but M1 L1 square plus M2 L2 square. And if you know L1, L2, if you L1, L2 here in this equation, you will get this. Okay, this I. So this is for example, just for you to understand. Now it's a good time for you to just go ahead and try out this problem. See if you can solve this. Okay, and then come back and check the solution. Okay, before we attempt to solve such problems, especially dealing with two-body problems where they are attached with spring or something like that, then we should just see what's going on. It's very important and sometimes it's eye-opener, and then you will get the concept and the path towards the solution. Okay, so let's draw a line here. Kind of symmetric arrangement here. And so these two bodies after some time will be like this. Okay, they will collide with each other. And after collision, this will move in this direction. This will move in this direction, while this will continue to move in this direction. Okay, and then they will separate and somewhere they will compress each other fully. Okay, and after compressing completely, they will start coming back towards each other again. Okay, and then this will happen with this arrangement. This will move in this direction, but this will change the direction and go in this direction. Same here. Okay, and then once again when they collide, this will change the direction after collision, and this will continue to move in this direction. Okay, and that's how they will separate. Because if you don't analyze this, then on the surface it seems like they will collide with each other, they will compress, they will come back, and they will again collide, and they will again compress, and then will again come back, and it will go till infinity. That's not the case. If you analyze this, if you see how these two bodies will again separate with each other and go in opposite direction, and then after some time they will again reach to a point where the separation is L. Okay, and both of them this time is moving in this direction. Okay, so I hope you see this. This is very important for us to understand. And then if we do that, then it's pretty easy. Then we can solve this problem really easily. So let's calculate the time t1. T1 is from here to here. Okay, how much time it takes for them to collide, and that is nothing but L by 2 V0, right? That's the time when they meet with each other. Okay, and what happens after collision? They will try to do oscillation here. You see, from here to here there is oscillation going on. And how do we find the oscillation, the time period for the oscillation? Let's say time period for the oscillation is T2. Okay, and that is going to be, what do you think? Will it be time period or time period by 2? It will be time period by 2, because the full oscillation would mean that after compressing, they should have not collided but extended also to certain distance, right? And that would be the one full cycle. But since they are colliding, so the T2 will be the half of the oscillation. And after this, for this particular case, since they are separating again with the same velocity, and you will see why this is going to be same velocity, because the momentum is completely conserved. If you treat it as a single body, right, then there is a conservation of energy, and there is a conservation of linear momentum also, right, for reduced mass. So we can say for reduced mass, so the momentum is conserved and energy is conserved, right? Okay, so the T2 again will be nothing but L by 2V0, right? Okay, so they will take T1 time to cover this distance, and again same time, let's say T1, to cover the exactly same distance. All we need to do is find out the T2. Okay, so for T2, let's use the energy conservation. Okay, so how do we write in a reduced mass scenario? We can say, well, half mu is a reduced mass, V square equal to half kx square. Okay, I hope you see this part here. Okay, now what is mu? Mu is m into m by m plus m. So that is m by 2. So then this becomes m by 2 v square equal to kx square. Therefore, v square is 2k by m x square. Okay, and v is 2k by m x. We can just differentiate this v with respect to x, and we will get 2k by m, and v dv by dx is a, and that will be 2k by m x, because we are multiplying dv by dx with v. So this will become 2k by n, and that is omega square x. Therefore, time period is 2 pi by omega, which is 2 pi into m by 2k. Therefore, T2 is T by 2, and that is pi into m by 2k. Therefore, the total time that is required by the question is 2 into T1 plus T2. Okay, and this is L by V0 plus pi m by 2k, and this is the answer. This is the answer. Okay, I hope you understood this question, and you also understood the concept here. This problem seems formidable, and we don't know how to even approach this problem. But when you draw some diagram, when you analyze the motion, then it becomes very simple. And since there is no external force here, so we could just reduce the mass and use the reduced mass in the equation. That's it. We didn't do anything else beyond that. Okay. I hope you like this video. Please do subscribe and share the video. Thank you very much. Subscribe and gain access to concepts and tips for doing better in IIT JEE or other examinations. Keep up the great work.